Meerkat is a Python library that helps folks use machine learning to wrangle unstructured data like images, audio, video, and text documents. Imagine that I'm a software engineer working on a tool like Zotero, a reference management application for researchers. As an engineer working on Zotero, it's really important that I understand what kinds of papers people are reading, so we can develop the right features and maybe introduce some recommender systems into the platform. For example, we might want to explore trends in popular research topics. But since scientific papers are just long text documents, traditional data science tools like pandas, which operate over structured data, fall flat. This is where Meerkat can help. Let's start by finding some data to explore. How about this? A dataset of over 1 million scientific papers from arXiv. This is a great dataset to explore with Meerkat because most of the information in this dataset is trapped in PDF documents. We'll start by importing Meerkat and reading the data into a Meerkat data frame. This dataset is pretty big, so we'll back our data frame with Apache Arrow. Next, we'll start up an interactive server that will allow us to visualize the data frame right in the notebook. With it set up, we can output the data frame from the cell and visualize the data in a spreadsheet-like table. We can see in the table that there's a bit of structured data on the papers included in the dataset, like the authors, title, and some categories. But where are the PDFs? Since there are over 1 million in the dataset, they aren't actually included in that initial download. To get them, we can create a new column for the URL of each paper and pass it to a special function called mk.files. This is a function that is central to Meerkat. It creates a column that streams in the PDFs from the URL as they're needed. It's difficult to explore the PDFs in a spreadsheet, but what if we had a different view of the data frame that allowed us to better visualize the PDFs? Meerkat provides a bunch of different ways to visualize data frames beyond spreadsheet tables. For example, with a single line of code, we can create a gallery which displays the first page of each PDF in our dataset. We can focus in on specific rows of the data frame and see the PDF alongside the metadata that we mentioned earlier. In the gallery, we saw that the dataset includes PDFs from a huge range of scientific disciplines, from astrophysics to geometry. Let's filter the dataset down to a topic we're more familiar with: statistical machine learning. Meerkat helps users answer statistical questions over their datasets. So let's ask some questions. I'm curious about whether people publish more papers today with empirical experiments than they did in the past. So this would be an easy question to answer if we had a metadata column is empirical in our dataset. But we don't. So here's the fun part. What we're going to do is use some large pre-trained language models like GPT-3 to extract the is empirical column from the unstructured data. It's challenging to prompt language models to correctly extract structured data from unstructured data, and it's even harder to validate that it actually works. The Flashville view helps us overcome these challenges. First, it allows us to select between a few different language models that we've registered with Meerkat. Next, we'll write out an instruction to the language model, telling it to output whether a paper includes empirical experiments. Language models tend to perform better when we give them a few demonstrations of correct behavior. So we'll create a training example template which references columns in the data frame. Notice that the last column mentioned in the template is the one that the model is tasked with filling out. Right now, that entire column is empty, but we can read a few of the PDFs to get correct answers for a small set of training examples. Using these demonstrations, the language model can actually fill out answers for additional rows in the data frame. Now, when working with language models, it's super important that we actually go in and verify that the model's working correctly. Doing this requires some amount of manual inspection. Meerkat's interfaces are designed to make this verification process easier. Here, we quickly skim the abstract in PDF to check whether the model's output is correct. On this small sample, it looks like it's working pretty well, so let's go back and fill out some more rows. Now, this is a good time to pause and point out an important feature of Meerkat. This Flashville view was implemented in less than 300 lines of pure Python. Data frame views like this one are developed using Meerkat's interactive development framework, which allows users to compose GUI components into fully fledged data apps. Because it's all done in pure Python, data teams can customize existing data frame views or create entirely new ones on their own. Creating new apps involves simply adding graphical components to your existing data analysis scripts. The components control the underlying computation graph of the script, which automatically re-triggers when users interface with the components. For those familiar, this bears resemblance to the scripting-based model popularized by Streamlit, but it's optimized for labeling-heavy applications. Okay, back to our PDFs. Once we've got confidence in the quality of our prompt, we may want to scale up to the full dataset. Doing this is sometimes easier in code than in a GUI, so it's important that we're able to transition from the GUI back to code seamlessly. We can access the prompt we created in the Flashfill component using the Flash object's prompt property. We'll pass it to mkcomplete, a Meerkat abstraction that applies a generative language model to each row in a data frame. mkcomplete is part of Meerkat's extended data frame API, which goes well beyond what structured data analysis libraries like pandas provide. We identify a core set of operations that repeatedly surface in unstructured data analysis and abstract them away. Other operations included in the new API include slice discovery and embedding-based similarity search. We've now filled in the isEmpirical column in the data frame, so we can start answering some of the questions that we posed earlier. To do this, we'll use yet another view of the data frame, which is a plot view, behind the scenes powered by Plotly. First, we'll plot the number of authors on the paper against the isEmpirical column. Doing this, it looks like the empirical papers tend to have a few more authors than the theoretical papers on average. Next, we'll plot the fraction of papers that include empirical analysis over time. Finally, we can write the data frame to disk using mk.write. Under the hood, data is written using the arrow format, so writes and reads are fast. But we also keep track of the PDF column and custom formatters for later reuse.